All right, here we go. This is going to be the GO 5.6, correct? Or 5.7, sorry, 5.7. Wait. Yeah. 5.7, okay, because we're going to skip 5, 5, 5, 6. Go straight to 7. Okay, questions, and so far 30, 31. Okay, now to deal with this, we need the Pythagorean Theorem. Okay, so Pythagorean Theorem is a squared plus b squared equals c squared. Okay? And just making sure it doesn't look right when it is. Okay. And whereas you have a right angle, right triangle, okay? Your legs are A and B, and your hypotenuse is C, okay? This is one of the most important theorems, and you guys have seen it for years. I mean, we talked about it in Algebra 1. I know they talked to you about it in 6th grade math, 7th grade math, 8th grade math. I mean, you see it your whole life. So it's one of the most important theorems we ever came up with. Pythagoras is one of the most popular people in mathematics, you know. Between Pythagoras and the Babylonians, and of course Isaac Newton. I mean, these guys are all just super popular, right? Because the Babylonians found pi, or, you know. So, I mean, there's a lot of really popular people in mathematics, but Pythagoras is definitely, I think, the most popular. And it's basically because of this theorem. So there's a relationship with right triangles, okay? And one thing we know is that when you have this right triangle relationship, it's easy to find this leg, and we could call it A or B, it doesn't matter, okay? And what's nice is these Pythagorean triples. So I'm going to give you 3 or 4 triples, right? And it's 3, 4, and 5, okay? And it's 5, 12, and 13. Okay? And is it 7, 24, and 25? Okay? And then I believe it's 8, 15, and 17. All right, and when you bind these, right, it's like 8, 15, 17 is like 64 plus 15 squared is 225. Should equal 17 squared, which I think is 89. So what is that, 289? And then, yeah, so then when you add this is 289. So that's 9 and 8, so 289. So that makes sense, okay? So that's what's going on. It's like 3 squared is 9, plus 4 squared is 16, and you add those up, that's 25, which is 5 squared, okay? So when you look at this, you can look at it and go, wow, I see that this is really 3 times 3, and this is really 3 times 5. So this should be 3 times 4. And what is 3 times 4? 12. That means that side is 12. If that side's 12, then this side has to be 13 for them to add up to be 25, right? Okay? But if you don't see the Pythagorean triple, then that means you have to do the math, right? So you're given that a squared plus b squared equals c squared, right? And that's what you're given. Or actually, you're not really given it. You're told that that's the Pythagorean theorem, right? Okay. And so then you plug in some points, which is substitution, and you go, well, then the 9 squared, right? Or in this case, we're calling that b, so we'll go 9 squared plus b squared is equal to 15 squared, right? And then you'll go, well, shoot, that's 81 plus b squared is equal to 225. Then you'll subtract 81, right? And you'll get b squared is equal to 4, and then 80 from 220 would be 140. So it's 144. Okay? And then you square root both sides, and you get b is equal to 12. And all these points, 2, 3, 4, 4, and 5, right? So to get here, you did substitution. To get here, you did the exponent, so simplification. To do here, to get the 4, we did subtraction property of equality. To do 5, to get the 5, we did simplification, right? So we know what 12 is, and then we'd have to plug that in. Okay? And then we know that these 2 points, right? We know that this segment and this segment, right? So y, we'll call it, so 6 is y plus 12 is equal to 25, and that's what we would call segment addition postulate, right? From chapter 1. So when we add 2 segments, they equal the big segment, right? And then subtraction property of equality. Okay? So y is equal to 13. Alright? And we had to make up our own thing. Alright, but that our own y. But that's okay, that's part of math. Okay? So we know this is 13 and this is 9. Now, I don't see a Pythagorean triple here with 13 and 9, do I? Okay? So that sucks. So that means we actually have to do the Pythagorean theorem on it. This was what? Subtraction property of equality. Right? So that means that we have to plug it in again. Because we already have this, so we can use that as a substitution. Okay? So we say, okay, 13 squared plus 9 squared is equal to x squared. And that's the one we're trying to find. That's the whole key, is we're trying to find x, right? So what is 13 squared? Is 1